You have to stand there.
Are you going to tell me when to turn next?
I will like nod, and that's how you'll know to turn next. I'll say nod.
Then I have to watch you though.
Yeah, it's true. All right, well, we're going to get started. It is 9 o'clock on a Friday. The bar's been open since 5. So being a data person, the lady behind me is counting you guys as you nod off while I talk. So that's one. If you fall out of your chair, you win the prize. So, okay, so I'm going to get started. So I'm John Plateus. I'm going to talk about predictive analytics and some of the tools that are readily accessible to people who probably don't use predictive analytics on a daily basis. I'm going to apologize right now. I don't have the word hash anywhere in my discussion. Okay, there's no MD5, no SHA-1, so I'm sorry. Okay?
You're talking about predictive things and hashes. That's
Shh. Anyhow, when I first talked to Mike, if you haven't met Mike Getzman, he's the guy that runs this, and you definitely got to make sure that... There he is! Okay, so if I have to give the shout-out moment here, if you have complaints, you talk to him. But more importantly, this is a huge accomplishment. It was at last year's. Last year's was half this size, and it just gets better and better. So make sure you give him a nod before you walk out the door. Anyhow, the question Mike asked me when I said, yeah, I'll come and talk as long as there's free beer, was, well, why on earth would I want to date a guy at a HackerCon? Because I already told him, Mike, that the word hash is not anywhere in my discussion. So, you got to think about the grand theory of hacking in general. Because the average public kind of have this tremendous misconception of hackers. That there's this malicious basement dweller in front of 9 giant screens, hacking people's Facebook accounts and getting giddy when they do it. I got another one. Okay. This is this general impression. Okay, but that's not what it is. We know that, because really at its core, the term hacking has to do with, somehow altering and manipulating what we already have to get to something we don't. Or taking something that's already been created and tweaking it in such a way that it's new and different. Right? See the word at the bottom? It says right? Right. Okay. So, I am going to then argue that as a data miner, data is like the ultimate hack. I mean, it really is. Let's be realistic. How many of you in your jobs have ever had somebody high up who shouldn't even know your name come ask you for data? I mean, show of hands. I won't ask you to do that often. But yeah, and you know what? Those of you that didn't raise your hands, you're lying. Okay? Because they do. We live in a data-driven universe. So, data mining becomes the ultimate hack. And here's the testament on the bottom, and that's the only thing I'll read off the screen, but it's the truth. With it, we can gain knowledge that can benefit mankind. Absolutely. We can alter human perceptions. You show people data. You present the data in a way that promotes an argument, and it becomes gospel. You can change the course of human history. You can alter the trajectory of a billion-dollar company with data. You can take what you have, manipulate it in a new and interesting way to discover something you didn't. hacking right there. It's awesome. But I'm sorry, there's no hash involved. Okay. So, with that said, and this is my disclaimer, the reality is you can do all that. I mean, you really can. I'm not joking. I do it. Millions of dollars hinge on the data that I produce and the way I produce it. People's lives change based on the data I produce and the way I produce it. So the reality is that somewhere within that comes a certain ethical responsibility to ensure that you're presenting data in a logical, in a reasonable, in an efficient manner that portrays the greatest similarity to the truth possible. So, just to give everybody a little bit of background on me, and again, she's counting the nods, so I'll know who does it. There's always been a question, and again, I'll kind of get to the notion of where this fits with information security in a moment. But, you know, there's always been this notion of, okay, in order to be somebody who's into data, you have to have a certain disposition. Again, there's that basement dweller surrounded by calculus books, and, you know, that's who gets into data. Well, the reality is that that's not all that typical. Statistically, the average millennial will have 17 jobs or 17 different careers throughout the course of their life. Okay, so depending on where you are, I think I'm on number 6, you undoubtedly have been exposed to and used data on a regular basis to draw conclusions and share information with others, oftentimes in an attempt to persuade them to your train of thought. So this is me in a nutshell. A long time ago, I started as a retail manager where I was responsible for implementing SIM's strategic inventory management system running on the ever-popular AS400. They don't die. It just is amazing. I've walked into billion-dollar corporations and they still have them because they don't die. Okay, so you learn a little bit, but the truth is that wasn't my primary job. My primary job was catching 16-year-old shoplifters as they tried to walk out the door with $4 of bubble gum in their pocket. Okay? But despite all that, data played a very important role in my life as I track and maintain market research to promote sales within my organization. Again, taking what I know, hacking that to produce something that I don't know, which then promotes sales within the organization. Okay, so on my trip to data land, start there, and then I become a history teacher. So, again, as you think to your own life, because I'm not just walking down memory lane, as you think to your own life and what you've done in order to get to where you are, we all have very different backgrounds. What I'm trying to convey, and I won't go through my entire life, is the fact that data plays a critical part in your day-to-day affairs. And as an IT security specialist, you more and more have to become responsible for the data that you use in order to make intelligent decisions about your organization. Because let's be realistic. Statistically, the odds of the basement dweller hacking your organization are pretty slim. Okay? It's true. Statistically, I mean, I was in a presentation earlier today where they were talking about different methods in order to ensure that passwords are properly hashed and continuously rehashed to ensure they can't be hacked. Someone will figure it out, but realistically, it's not going to impact you guys at all. So, ultimately, as you make decisions for your organization, you're going to have to decide what's important and what's not. And the only way to do that is by effectively looking at the data you have available and being able to make intelligent decisions from it. So, where does this fit in information security? If I can get that to play, because I refuse to use the wireless here. Can you see if you can get that? There it goes.
Instead of deleting them, I decided to hit
Hang on.
I got an email about some diamonds. Here's what
We need some volume.
I got your contact from a South African health officer in Ghana. I find that
You don't know how to do it?
I need to move 1,000 carats.
Feeding through the HDMI cable instead. That's might be the best option.
Hang on. All right. All right, we may not get the great joy that is that video. Does everybody know that when Bill Gates introduced Windows XP, it blue screened during its reveal?
That's the blue screen there.
Yeah, that's the blue screen of death. All right, well. Ah, bummer. I love that video. All right, anyhow. We won't spend a lot of time troubleshooting. Anyhow, if you have the opportunity, just go ahead and go Google Toaster Scam-A-Lot. This particular individual, you know how you get spam mail? The stuff that we all spend a tremendous amount of time trying to block within our organization? Well, this is the guy who responds to it. And so he's made an interesting living being the person who responds to scam email until the point where the scammer asks him to stop emailing. That's his goal. Okay, so I'm not going to tell you the story because the truth is it's quite funny, and I think you should watch it because he'll definitely do a better job than I would explaining it. But he has multiple situations where he gets scam mail about, $2 million in diamonds, and all you need to do is set up an account in the bank, and he responds. And works with these people until finally they can't take it anymore, and the scammer tells them to stop calling him or stop emailing him. The point of this is the fact that people do strange things. So coming back into that security mode, people just do weird things. And when people do weird things, it has a tendency to impact our organization. I'm not talking about the basement dweller anymore, and please, I'm not trying to offend anyone. It's just trying to be funny. I'm talking about the average person on floor 6 whose machine continuously becomes infected regardless of how many times you clean it, and tell them, please, if you didn't order anything from UPS, don't click on the attachment in the UPS email. But it could be something cool. No, it's not. Okay? So, what we need to do, here's the problem. And again, I'll ask you to raise your hand. How many of you are overstaffed? You didn't hear me. How many of you are overstaffed? Yeah, I know. Oh, it doesn't matter. Pick one. Okay, the reality is none of us are overstaffed. I'll give you an example from my own life. Although I won't go into what I do or my company does, I will tell you my responsibility is to make sure Black Friday works. I am literally on speed dial for banks around the globe for Black Friday and Cyber Monday. And then Tax Tuesday. Those are the biggies. And if any of them have problems, my phone goes off. Okay? So obviously that sucks. So in order to ensure that it isn't a disaster, I have to use predictive analytics to make sure that I predict every possible outcome and ensure that I've addressed the reasonable ones. In IT security, that's your problem too. Okay? The truth is, you can't stop the nut. Okay? But they're an anomaly. Your bigger problems usually have to do with your average everyday user that makes bad choices at the wrong time. And you don't have the staff or the supplies or the software or the money or the executive endorsement to ensure that all of that is fixed. So you have to pick your battles. And that's what we're going to talk about. How you can use something that you can download the minute you walk home, unless you're a huge programming geek, and if you are, R is spectacular. Okay? But, you know, you also have to be glutton for punishment to learn it. Okay? So, next one. Here's why I'm talking at a HackerCon, and I've kind of alluded to it. The fact is that we have issues. You don't have enough staff. You don't have the resources you need. Your job gets bigger by the day, and you need a method to pick your battles. So that's why you need to become data scientists, because you needed something else on your plate. Yes, thank you. But you do, because it will make your life in the long run a little bit easier. And here's why. Because without data, opinions only exist because of lack of data. I love that. Okay? As you pick your battles, you need to know what and why. Statistically, the #1 demographic group for shoplifting in the United States is women, white women, between the age of 40 and 55. Is that who mall security watches? They didn't pick their battle right. Okay? Give me data or give me no. I just love that phrase. And then without data, you're just another person with an opinion. We need data. You need data to pick your battle. Or you need more staff, and we all know how well that argument goes over. Okay? So, in order to become data scientists, and particularly good data scientists, you need to kind of keep in mind that you're dealing with a general public that doesn't have the data. You have it, you own it, and you get to decide how, where, why, and when they get it. So some of the things we're going to walk through, because I am going to get to the point, I don't just like talking. Some of the things we're going to talk through are going to be those pieces that are going to help you do that. And I will leave you with a very famous quote on this slide from Mark Twain. And it comes back to the idea that as you are the guardians of your data, and you really can decide what you show to other people, you need to keep that ethical factor in the back of your head. So Mark Twain once said, there are 3 kinds of lies. There's damn lies, and there's statistics. So people are already somewhat skeptical of data. So you need to make sure that when you're challenged with using data to manipulate people's opinions, that you do so in an ethical fashion. Okay. So what we're going to talk about, this is like predictive analytics, machine learning 101. This isn't a 12-hour session. I'm not going to give you an extensive demo that you're going to forget as you count down the seconds till bar close. Okay? But I am going to make sure that you leave here knowing tomorrow when you wake up, well, it's Saturday. It's a work day for IT people. You need to know that tomorrow, here's what you can do to pick your battles. 2 things we're going to look at. Supervised learning and unsupervised learning. Okay? These 2 terms get thrown around a lot. I'm going to try and put them in layman's terms, not because I'm concerned that you can understand the technical term. I'm concerned I don't understand the technical term. So I'm going to put it in layman's terms. Supervised learning is you are predicting something. You're taking your data and you are discovering something you don't already have. Okay? Unsupervised learning is you're taking your data, you're not predicting anything, you're just grouping it in logical ways to ensure that you have an answer to a question. You actually get to hire new people, but you know what? Your last 3 people stole from the company and got fired. Your judgment is in question here. So how do you pick the right people when you got 3,000 applications? I can do it in less than 3 minutes without looking at a single resume. Okay? That's unsupervised learning. And I will show you the tool and the particular piece in order to do it. Okay. Let's go on to the next one. All right. What you see up here, and again, thinking in terms of data mining 101, is kind of the process. And you know what? I don't know about you guys. I hate process. I just want to get to the fun part. Okay, that's why I do this. It's like when you have to fill out change tickets at work, even though you could do the change in like 8 seconds. I don't know about you guys, but I can build a server in minutes. Why does it take 2.5 months? Anyhow, unfortunately, both my argument for why we don't need process where I work has, and I'm going to tell you, you can't skip the process when it comes to data mining. Here's why. Give the wrong data to the right people at the right time, and you're screwed.
Battery might be dying that one if that's what happened.
Because they will never, ever let you forget it. You remember that time? You remember that time, you know, you gave me the wrong data? Ooh, yeah, you don't want to do that. So you have to go through the process. And again, I'm going to put the process in layman's terms, not for your benefit, for mine. First one is business understanding. Do not skip this part. In IT, in security, in business, in whatever you do that revolves around data, particularly tons of it, because we live in a new world now. Storage is cheap. You can keep tons of data, and companies do. Some of us support it. Truckloads of data about random junk that nobody will ever need, but we keep it because it's cheap. And then the CIO calls you at 4:43 on Friday and says, I need to know this. Okay, here's the problem. And I'm going to tell you, you got to do it because he's going to get real angry with you on the phone. I just need to know this. Hang on. You got to tell me specifically what you want, what you're trying to show, and who the audience is going to be. I'm going to say that again. What you want, who you're going to show, or excuse me, what you're trying to show, and who the audience is going to be. Oh, remember that. I'm saving you heartache because when you give them the wrong stuff at now 6:48 on Friday night, and he calls you back up and says, that's not what I asked for. You got to make sure he spells it out. So, in the very first phase, you have to understand business understanding. Okay? You need to know, you need to stop and ask the critical questions, because here's the reality. He don't know what to ask. He knows what he has to show. And he wants you to just do it. Now, I don't have time to talk about this. Just do it. My CIO is not like that, by the way, so I'm exaggerating because I know this is being filmed. Anyhow, you have to make sure that you understand what's going on. You have to ask the critical questions. You need to talk about how frequently you want this data, because it may be something you can produce on the fly, but not something you collect on a regular basis. Or your data collection methods may change over time, and in doing so, change the deliverable. You need to understand the audience. If this is going to C-level management or if it's going to be presented to the board, okay, a little bit different. If it's going to be distributed in a newsletter to the shop, a little bit different. Okay? You need to know the anticipated outcome, and sometimes they don't know. You have to read between the lines. I'll give you some use cases where that's kind of obvious. Don't skip this step. Do not get off the phone with the guy or the lady or whoever's asking until you know what is being asked for. Okay, how do you do that? Number one, you interview people, particularly the business leaders, the SMEs. I've done focus groups because, again, people don't always know what they want. Okay, surveys, all that good stuff. Get creative. You need to know what's being asked. So, here's some examples of the types of things that we can be asked that, aren't so easy to come up with. I love the top one because it's probably the most typical one that I hear. Your employer wants to understand the rate of change and trajectory of identified malware threats across the enterprise. It's a logical question. How are we doing in security? Is it getting worse? Is it getting better? Are you doing your job? Is really the question. Under the covers. He wants to see if what you're doing is actually improving, maintaining, or insufficient before deciding if he's going to approve those 2 new recs and the renewal of that software you like. You have to read between the lines. You need to hire 3 new security I didn't write that right. Security analysts, but they have to meet strict criteria. Again, I bring it back. The last 3 quit. And that one dude stole that guy's lunch. Okay? We need to make sure you're picking the right people. One of your offices has more malware threats detected than the other. What's going on there? And why haven't you caught it? Your company has just acquired another. You're not getting any more people. But you've doubled in size. So, your CIO has asked for a recommendation for hardware, software, and personnel to ensure security is not compromised. Between the lines, I need you to show that you can do it with no additional cost to the company. I love it. I see all these nods going, yeah, I've heard that one. Okay. So, point of all that. There's 1,000,001 use cases. You have to read between the lines. You have to understand the purpose. So, once you can do that, here's the second part. You probably don't know how to answer the question yet. And you know what? I've become accustomed to not being the smartest guy in the room, and I've learned to accept it. So maybe you do know how to answer the questions, but I can tell you 70% of the questions I get asked, when I'm asked it, I don't know how to answer that. I don't know where I'm going to get the information, and it's 4:43 on Friday. Again, dang it. So we need to understand the data that it's going to take to answer the question. What's available? Where do you get it from? The next part of that question. In what format? Oh, I love that. Because that lady on the 3rd floor has that data on a spreadsheet on her laptop. Why is it there? What does it tell you at first glance? People say you should trust your gut. As a data person, I cringe when I say that, but the truth is if you know how to look at it the first time, you can save yourself a lot of wild goose chase. Okay? Will it meet the business objectives? So, as you think about these things, some of the things that come up is, well, all right, well, what do I do about that? You'd be shocked what you can do in Excel. I don't know about your guys' company, but for some reason, mine lives in Excel. Excel and PowerPoint. I mean, that's how we communicate. So, okay, the truth is, Excel's pretty awesome if you can use the behind-the-scenes stuff. That's all right, but this is the 21st century. My quote on the side is learn SQL. I love SQL. I love R and SQL, so I'm glutton for punishment. That's just me. But if you really get stuck manipulating a truckload of data, learn SQL. Learn R if you really get stuck with this a lot. Okay. What's that? Oh, I'm sorry. Was that a joke? It's fast enough? Oh, I want to come work by you. I've never even seen it be fast enough. Okay, so your ability to see your data, and again, I'm coming back to the step 1, or this is step 2, excuse me. You're understanding your data. It's 443. The CIO wants his questions. And here on the top left is the trend of malware detection across the enterprise over the last, what did I give it? I think I gave it several months. You can't show them that. Well, you could. I'm just trying to think of the questions that would come out of that discussion. Gee, boss, how am I doing? This is the number of threats and the trend in our organization. We're doing fine. The next question is going to come out, how'd we get there? So then you can look at on the bottom. Here it is. Here's the number of threats distributed across the different departments. Well, apparently computers, electronics, and the jewelry department, they're just the worst. You know, you get all them the in your computer departments. Well, we're all in computer departments, but I don't know about you guys. I'll confess, I've installed random stuff just to check it out. And, you know, it happens. Usually I was the only one that knew it happened. But, you know, in larger organizations, particularly ones with a strong data strategy, other people will know. And, of course, then there's also, and again, this is all part of understanding your data, this is the relationship between men and women and the number of malware detection in their environment. The red, that's men. And then the other one is women. I'm just going to make it clear, this is bogus data, by the way. So I didn't do that on purpose, even though my wife is my number one most bothersome technical support requirer. Okay, but I didn't do that on purpose, by the way. Okay, next one. So once you've understood it, you've visualized it, you've drawn those initial conclusions, now you have to clean it up. 80% of your time is spent doing this, okay, because most data is dirty and it's full of bad stuff. The bank, I'm sorry, American Express, as of last year, they have spent 4 years building a centralized data warehouse of both structured and unstructured data using Hadoop. 4 years. And when I talked to their chief data architect, I asked him, 4 years, man. I mean, what's taken 4 years? He says, no, it's not compiling the data. That's real quick. You know, it gets really impressive, you know, when you're at 4.5 billion rows. It's like, He goes, but 2/3 of it is garbage. And we have to go through it because if I share that with my CFO, I'm going to get fired. 4 years. So you need to make sure, is the data there? Is there data you shouldn't use? My last slide. Who cares what gender's involved in the most? What are you going to do? Ban that gender from using the computer? That's just not going to work. I mean, there's like lawsuits and all sorts of stuff just waiting to happen. So you have to make sure that you remove data that doesn't contribute to your cause. Are all the entries logical and usable? Are they complete? Most analytics don't work with missing data. And again, when you think about the tools, I mean, it depends on what you have at your disposal. You'll see that there's two things that have a tendency to pop up. One's called RapidMiner, and the other one's called R and RStudio. If you haven't checked these out, free, download it, use it. RapidMiner was Gartner's 2016 Big Data Analytics Tool of the Year. And they have been in the top ranking for the last few years. I'm not trying to sell it. It's free. It's awesome. And if you look at the more commercial alternatives, like SPSS Modeler and SPSS, okay, I will preface this with this is my own personal opinion and not meant to sway or discredit any organization, but, you know, those things are old. They're antiquated. They're hard to use. They look like they were built in the 90s. Okay? So, great tool, by the way. Dude with the camera. Anyhow. So, they're all perfectly good, acceptable, huge parts of the everyday data mining community. However, if you want something to start with that you can use in your own organization to answer the 443 question from the CIO, use RapidMiner. It's awesome. All right, next one. Cleaning your data. Okay, on the right-hand side, you see a screen of what RapidMiner looks like, because right now there's a lot of people in the audience going, I don't have time to do this. I don't have the time. I don't have the interest. There's 3 people walking out the back door. We see you. Okay, so I don't have time to do this, and I'm certainly not going through that spreadsheet on the left. Okay, I can't do 77,000 rows of that stuff. Okay, this is what RapidMiner looks like. It's also what SPSS Modeler looks like and other tools that you can use for these purposes. Okay. All of them are certainly exceptional. Again, RapidMiner's free. Well, to a certain extent. That's how things work. But what you'll see is that it's a series of operational modules that you can include in order to manipulate your data over time. So, coming back, know what's being asked, get the data that you need, however you need to get it, clean that data so that it is functional, and then the next step is the actual fun part. So by this point, you're exhausted and you can't take it anymore. And, you know, now it's time to do the fun part. This is where we get to the modeling piece. In case anybody's wondering what that means. And again, I keep trying to tie it back to security, but the reality is this is all universal for anybody who works with data, particularly a large amount of it. Okay? When you talk about modeling, you're talking about taking your data to draw a new conclusion that perhaps isn't obvious in the first place. And you're going to do that by grouping it, or you're going to do that by using what you know to predict what you don't. The mathematical equations behind it, I've looked at them. I kind of get them. And then this is my own confession. There's some of them I don't even know how to describe that equation. That's some calculus guy at at Harvard, threw up one night, and that's what it looks like. So, but I understand what I need to get, and I understand which of those calculations is going to get me there, and I understand the tools that I'm going to use to do it. So, in this point, we're getting to the modeling part. We've done all the dirty work, using whatever tool suits us, including, the more commercial ones, which I prefer other ones. Go ahead. The modeling piece is the part you got to get to. That's the question or the answer to the question you've been given. So in this case, here's your malware threats over time. The question is, well, how are we doing? Well, it's not our fault. People just keep introducing new malware into the world. It's those darn basement dwellers. Are you keeping track of how many times I say that? That's only 4? Oh, I can beat that. Anyhow, Malware is going up, but the question is, where will we be in the future? I know where I am now. It's too late. Can't fix that. It crashed 10 minutes ago. Where are we going to be in the future? That's what we want to know. Will Black Friday of 2017 survive? That's what I need to know. So I need to use predictive analytics and modeling to do it. And in this case, I've stretched out the reality out another 120 days. And you are adding new malware to your environment at a rate of 1 every 10 days. So if we continue to go down the rate we're going to have bigger problems. We can model this. We can model it with a certain degree of accuracy, and I can even tell you how to get to the accuracy. So we've done the hard work. We've done the model. Next one. There's other modeling toolkits that you can use. If you're going to take any notes and you haven't fallen asleep yet, this is the gold right here. Okay, this is the stuff that when you get back tomorrow and you've rethought of all the things you learned over the last 2 days, and you think, what did the crazy data guy talk about? I don't know, it was Friday night and the bar was going to close. This is what you need to remember, because this is the stuff that it takes people years to figure out, and I'm just going to tell you. There's two things. We've talked about it. There's supervised and unsupervised learning. Let's forget those terms. You want to classify stuff. These are the ones you do it. You're 3,000 applicants and you have to find the top 5, and I need it by Thursday at noon. This is how you do it. K-means. Forget K. K, like in most things, is an irrelevant number. What it's basically saying is I'm going to take all your stuff and I'm going to group it into logical groupings, and you can pick the group you like best. If you look right here on the right-hand side, I did it. I took 1,000 applicants, all with different characteristics, and I picked the 100 that makes sense, and the rest get "I'm sorry, no thank you" letters. How did I do that? Well, I only want the ones with the most years of training. I want the ones with the most sophisticated certifications. I want the ones with the longest work history. I want the ones that have passed our background check and scored the highest on our screening surveys. I can't go through all that stuff. So in less than 3 minutes, and I'm exaggerating, the truth is it just takes seconds for 1,000, I already know this is the group I want. And I know there's 1,000 of them. I'm not reading more than 100. So I broke it into 10 groups, and I'm picking the best group. Now I can go on and solve all those other problems. Go back. We're not done yet. Couple things with K-means. It is simple. Okay, on the left-hand side, you can see it. This is the process. I'm going to read my data. I'm going to select the relevant data. I am going to choose the role. In other words, when I choose the role, I'm deciding what's the one that I want you to decide for me. And then I'm going to run the clustering module, and boom, like magic, it spits out what I want. All right, now you can go on. Yes. Basement dweller. Anyhow, as you add to that classifier group, another one's called Knearest Neighbor. In Knearest Neighbor, you take all your data, you let the computer group it, you find the ones that you want answered, like what will this new one go to, group A or group B, and the calculation will determine that based on distance from the K number of variables you choose to compare it to. So in other words, if I have 1,000 records, 500 are over here, 497 are over here, I've got 3 left, and I want you to divide the 3 into whichever group is closest by 3 individuals. It'll do it. It'll tell you who will get picked last for kickball. Next one, decision trees. These rock. I mean, these are awesome. If you, and I know, if you saw the first slide, I used to be a history teacher, so I run this against the Titanic data to see who would have survived and not, and why they died. It's really morbid. I'm really ashamed of myself. But the truth is, statistically, I'd love to get there in 1914. So much for the history teacher. I'd love to be there before they get on and run around and go, dude, don't get on the boat. It's not going to end well. Because you can determine quite precisely who was going to die and why. It's cool and morbid. Yes, I'm ashamed. Anyhow, in addition to decision trees, in IT, this is totally awesome. I love it. You can take that statistical analytics and you can build rules, and we do this, and it's totally awesome. Because you know what? A high amount of CPU, memory, or disk utilization on a system is not necessarily bad. Okay, you're getting what you paid for. That thing was expensive. You should be working it hard. But when a certain combination of events occurs, it always results in something bad. Nobody knows to watch for this, and this. Statistically, I can tell you what to watch for, create rules for it, and the minute those flags pop up, you get a phone call. How cool is that? Call me when a real problem is going to happen. That's a unique concept. Naive Bayes. I don't know where Bayes came from, but I'll tell you why it's called naive. It's called naive because it makes the assumption that all variables in your equation are independent. Okay? The truth is, they're not always. The nice thing about naive Bayes, it always works. Even if your data is flawed, it just seems to work. So, this is your toolkit for clustering. Next one. Oh man, nobody fell out of their chair yet. So when you use your toolkit, you can also use predictors. So forget the clustering we just talked about. We're taking all our data and grouping it to draw some conclusion. Well, now the question is, well, I don't need to draw a conclusion. I have one variable. I just need to know when bad things are going to happen. And that's where we use our predictors, particularly linear and logistic regression. Here's my plug for R. This, to do all this, is one line of code in R. Okay, it's totally awesome. But if you like the boxes, you can use SPSS, you can use SPS Modeler, you can use SAS, you can use RapidMiner. All of them have variables built in for logistic and linear regression. If you look at the bottom right, that's what it does. It takes the data you have, it determines a reasonable statistical trend, and forecasts it out as far as you want to go. The difference between linear and logistic, linear works with numbers. Okay? Logistic works with yes or no. Will you die on the Titanic? Logistic. How many days do you have left to live on the Titanic? Well, yeah, sorry, not many. All right, next one. All right, we're almost done. Next one. We've done the work, right? We got the request. We determined what was asked. We identified what I needed to collect. We cleaned it up, and we even did the fun part, the model. Okay, but it has to pass the smell test. You can't just send that model off to somebody. I mean, they never turn out right the first time. Okay, it has to pass the smell test. If you've ever done P to V migration analysis, okay, it's a disaster, right? Your model 8-year-old hardware onto brand new next-gen blades. They go from 128 CPU down to 8. And you hand them that and they look at you like you grew a horn out your forehead. That's not possible. Well, statistically it is. Okay? But it has to pass the smell test. You have to look at it. You got to make sure it's right. And the way you do that, if you look at the next slide, my accuracy look at my Titanic people, 45.67%. Well, you might as well guess. You're a 50-50 shot anyway. Never comes out right the first time. Sorry. Why doesn't it come out right? Because the first time you do it, you include everything. You have to figure out which variables are important and which aren't. Keep in mind, the best way, well, it isn't the best, but the simplest way to determine accuracy is using a confusion matrix. I love that term. Yeah. That just doesn't make any sense. How do you know if you're right? Well, you check the confusion matrix. Almost sounds like a bad joke. And basically what it does is it says, well, look, I'm going to take the number of predicted true and the number of real true and see how close you are. And the number of predicted false and the number of real false and see how close you are. Most tools do this for you. RapidMiner, it has a module, and I keep coming back to it because you can go home and download it when we're done. Has a module called performance. It'll tell you. If it's less than 95% accurate, well, yeah, go for that. You hand that off to your boss. Okay, if it's 50% accurate, that's, yeah, no, don't use that. So make sure it's accurate before you send it on. All right, next. Last part, once you've done it, you've done all of that stuff, you get to the point it's time to deploy it and put it in production. That's when you hand it off to your boss. I'm going to recap it quickly. You started out with the critical question. You get them all the time. More and more. If you don't get data-related questions now, can I come work by you? Because it's all I get, but that's kind of my job. But it's all data. You want more money? Show me the data. You want more people? Show me the data. You don't want to get fired because the Bank of Singapore went down? Show me the data. You need to use data to help people draw accurate conclusions. And in security, you have to do it too. This is the process. If you follow this process and you use one of the tools that you have available, when you walk in there and they say, hey, how's it doing? How's it going? Are we still having security threats on the East Coast? Yeah, it's the East Coast. What do you do about it? That's why we all live in the Midwest. All right. Did I have anything after that? No, that's pretty much it. So I come back to the very last thing. I want to wrap this all up in a bow for you because, you know, there was no hash algorithms. I love group policy, by the way. Group policy rocks, but I'm sorry, there's no group policy in my discussion. It all comes down to once the hackers are done, once you have manipulated, changed, or gained access to something in order to gain new insights, well, then what do? Then you have the data. And oftentimes, the data is something that your boss, your boss's boss, or worse yet, your boss's boss's boss, who sure really shouldn't even know who you are, will come right to you and ask for the data. And you have to know how to deliver it in a way that is both accurate and provides direction for the next steps. This is how you do it. And if you follow these steps, you're going to be successful even if the answer is not what they want to hear. So there you go. Any questions? Yes, hi.
How do you deal with adversarial input? For example, the academic paper that came out recently that shows there's a mass of input over an image, and it's more or less just predicted with human, but it'll confuse all of these machine learning algorithms.
Well, that was great. Next. I figure if I don't talk long enough, you'll forget you asked the question. The truth is, I don't know the answer to that. It's a very legitimate point, and here's part of the problem. Statistical analysis is ancient. So everything that we just talked about is the computerized version of intelligence that in some cases date back to the ancient Greeks. Okay, so this is not new. Having a machine do it, and do it with some level of accuracy that makes human interaction less and less needed, that's new. So the only thing I can say to that question is that it's part of an expected learning curve. As those types of situations arise, the algorithms and the people who produce the tools to use those algorithms have to mature with it. I know that's a real cop-out answer because but that's what I got. Okay. Other questions? All right, I appreciate everyone's time. I hope that a little bit of data talk didn't bore you too much. Everybody have a great evening, and thanks for coming. And if you see Mike downstairs, give him a high five because this really was an awesome conference. So, oh, there he is. You can't miss the pink shirt. All right, guys, thanks.